September 10th, 2012, and these are the notes that we're taking for homework. We're going to cover a few things. We're going to review absolute value in our expressions, so in our algebra expressions. We are also going to evaluate algebra expressions. Okay? And we're going to look at the distribution property. Now, the interesting thing is that these two components make up the evaluate algebra expressions, which means that we have to know how to work with absolute value and we have to know how to distribute in order to evaluate our expressions. Now, evaluating expressions, it doesn't mean solve for x. Okay, so I'm going to write solve for x. No, that's not what we're doing. Okay, we're not solving for x. We are actually just solving for by combining like terms. So we're looking at things that are alike, and we're getting our problem in terms of our smallest possible answer. Okay? So the first thing we're going to do is we're going to review the absolute value expressions. And the absolute value expressions, remember that absolute value sign are those straight lines. Okay? And inside of those straight lines, we can have a number, okay? Or we could have a negative number, so we could have integers inside of there. We can actually have a math problem inside of there, okay? Each of these things, what you have to remember with absolute value is that these groupings, these absolute value signs are grouping symbols, which means that you have to do everything inside of them first. So, for example, we could have a problem that was the absolute value of 20 minus 12. And to get our answer, we have to solve what's inside before we remove the absolute value sign. So the steps would look like leaving your absolute value sign, solving the inside. So 20 minus 12 is 8. And now we can take the 8 out of the absolute value signs by saying, what is the absolute value of 8? How many hops away from 0 is it? It is 8 hops away, and our answer is 8. Now this looks a little bit more complicated. Let me move my paper up. Like the problem that we had on our test today and on our practice test last week, it would say something like 20 minus 12 minus 18 minus 20. Okay? And in order to do this, we have to follow GEMDAS. And GEMDAS says use your grouping symbols first. So that means we have to do what's inside of these grouping symbols before we can do this subtraction piece. So we're going to say equals, and 20 minus 12 is 8. We're leaving it inside the absolute value sign. Minus 18 minus 20 is negative 2. And again, we're leaving it in the absolute value signs. Now we take them out of the absolute value signs in order to be able to subtract them. So the absolute value of 8 is 8, minus the absolute value of negative 2 is 2, and 8 minus 2 is 6. Okay? And it works the same way. I'm going to show you one more. It works the same way with multiplication, division. However these absolute value signs show up in your problem, you have to do what's on the inside of them before you can take their value out. So we might have 54 times 1/2 in an absolute value sign minus 4 times the absolute value of 3 minus 2 plus the absolute value of 15 minus 90. Okay, that's a bigger problem. Let's take it step by step. We're going to say equals. And remember, we have to do what's on the inside first. So I'm going to leave my absolute value signs and say 54 times 1/2. Well, we're saying what is half of 54? Okay, So half of 54 is 54 divided by 2. So if you need to, over here on the side of your paper, let me shrink mine so you can see it better. Over on the side of your paper, you can do your work. 54 divided by 2. 2 goes into 5 2 times. 2 times 2 is 4. Subtract, and you get a 1. You're going to bring down your 4. 2 goes into 14 7 times. So 54 times a half is really 27. Okay? I'm going to enlarge my paper again. So you have the absolute value of 27 minus. Now, we can't do anything with this 4 because we have this grouping symbol to deal with first. So we leave our minus 4 here, and we're going to solve 3 minus 2 is 1, leaving it in the absolute value sign, plus, and we have the absolute value of 15 minus 90. Well, we have to solve that before we take it out of the absolute value sign. So 15 minus 90, and again, I can use the side of my paper to say 90 minus 15. Remember, this is adding a negative. So my 90 is bigger, and my 15 is the smaller number, essentially. But this is negatives, and these are positives, so we're really subtracting. So we get 75, and it should be a negative 75 because I have more negatives than I have positives. Okay? So now my next step says, okay, I can pull these things out of their absolute value symbol. The absolute value of 27 is 27 minus 4 times the absolute value of 1, which is 1, plus the absolute value of negative 75, which is 75. Now, according to GEMDAS, I have to do my multiplication and division first. So I have to write my 27 minus and leave it there. And 4 times 1 is 4. And I have to add my 75 still. And now, work left to right with our addition and our subtraction. 27 minus 4 is 23. And I still have that 75 to work with. And 23 plus 75, and again, you can do your math over off to the side if you want. Or you can do it in your head. 3 plus 5 is 8. 2 plus 7 is 9. Okay, and I'm going to box my answer as 98. Now I'm going to turn my paper over, and we're going to deal with distribution. The distribution property okay, this is what we're looking at. And what we're saying is an example would be something like a 5 times x plus 10. This might be a good, simple, basic problem. Okay? And what we're doing is we're saying we have to distribute this 5 times the x and times the 10. So we say 5 times x is 5x. And then we have to keep our addition sign. And 5 times 10 is 50. Now, I have 5 x's and I have 50. Can I add them together? No. I can't add them together. Why? Because they are not alike. This is x, 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 x. There's 5 x's. And then there's 50 of these little pieces. Are they the same? No, they are not the same, so they cannot be combined. So this is my final answer. Okay, I'm going to do another example because sometimes we have a negative. So if we have a negative 4 times the quantity of x minus 3, I want to distribute my negative 4 to each piece of this problem. So I have to say negative 4 times x is negative 4x. And remember, we don't subtract in algebra. We're going to change our signs to say I'm adding the opposite. So I have my addition sign here. And negative 4 times negative 3 is a positive 12. Now again, I have x's and I have 12. Are they the same? No. So you cannot combine them. So you are done. That is your smallest possible answer because 12 cannot be combined with x's. They're not the same. Okay, I'm going to give you another little bit harder problem. It would look like 3 times the quantity of 1 minus 20 plus a negative 5. Okay. Now, there's 2 ways to do this problem. I'm going to slide my paper up. okay? And there are two ways to do this problem. So I'm going to zoom out and show you both ways. I'm going to rewrite it twice, and I want you to do this on your paper as well so that you can copy both ways of doing this problem, okay? One says, let's just use GEMDAS. So this would be the GEMDAS way. And then this would be the distribution way. So if your book is asking you your problem says use distribution to find the answer, then you need to use the distribution method. If you're in algebra class and you have to solve a problem like this, you can use either method that you want. Okay? So I'm going to say I'm going to follow GEMDAS, and GEMDAS says do my grouping symbols first. So here I've got brackets. Those are grouping symbols. The only reason that these parentheses are here is to show you that that's a -5. Now I don't subtract in algebra, so I want to add the opposite. And so my first line would be 3 times this quantity. I have to do what's in the grouping symbol first. So 1 plus a -20 is a -19 plus that -5. And I need to keep going. I can now combine these terms. This is a -19 and a -5, which means that you're going to get more negatives, so you're really adding them together. So I'm going to write my 3 and my grouping symbol, and 19 plus 5 is 24, and they were negatives. Okay? And now I'm going to do the multiplication piece, 3 times -24. So what I know is I know that 3 quarters, or 3 groups of 25, is 75 cents. So I can do 75 minus 3, because this is 1 off of a quarter. Or I can just do the math. 3 times 4 is 12, carry my 1. 3 times 2 is 6, plus 1 is 7, and it's negative. Okay, and so this is your answer. Now we're going to use distribution. So the distribution way that you do this problem would say 3 times 1 plus, and remember we add the opposite in algebra, 3 times a -20 plus 3 times a -5, and now we can say 3 times 1 is 3, plus 3 times -20 is -60, plus 3 times -5 is 15. And now you can add. And I'm going to combine the things that are positives first. And I'm going to say 3 plus 15 is 18, plus that -60. And I'm going to do my math over off to the side. Oh, -60, -15 here. I made a mistake. So you have go back a step. You have -15s and you have -60s. So I'm going to combine them first and get -75. And -75 plus a +3 is a subtraction, which gives you -72. And that's your answer. There's a second video, so make sure you watch the second video.